I'm starting with force, right? So, what is force? Force is force is any push or pull, right? Any push or pull which brings which brings change change in position of object, right? That is force. Its formula force F is equal to mass into acceleration, right? Acceleration. Mass is scalar quantity. Do you know what is a scalar quantity? And vector quantity. This is vector quantity. Vector quantity. So this is also force is also vector quantity, right? And force we measure mass in kilogram, kilogram, and acceleration in meter per second square, right? So force is Newton, 1 Newton, right? Force is measured in Newton. So 1 Newton is equal to 1 kilogram meter per second square, right? Okay. Now, if 1 kilogram is equal to 1000 gram into 100 centimeter per second square, right? So it becomes 10 raised to the power 5 gram centimeter per second square. This is known as uh, what we call Dime. This is known as Dime, right? So 1 Newton is equal to 10 to the power 5 Dime, right? So this is we have, and few more are like that. Uh, One is 1 Newton is equal to 0.1 kgf. Kilogram force is equal to 100 gf, right? Or we can say 1 kgf is equal to 10 Newton, right? This one and this you have to remember, right? And this is very important. This conversion is very important and it is very much required, right? So This is we talk about force, and after that, after the force, we will discuss about what happens when apply force. By apply force, what you do, you can bring object from rest to motion, right? You can bring moving object moving object moving object comes in rest, right? Bring object from rest to motion, moving object comes in rest. And next is alter alter the speed of uh, alter this can alter the speed of motion, right? And motion, and can alter the speed of motion, and bring change in shape and size. Bring change in shape and size. Right? And lastly, it brings change in direction. Bring change in direction, right? So these are the characteristics of motion, right? What I said, bring a moving object bring a object from rest to motion. Moving object comes in rest, can alter the speed of motion, bring change in shape and size, and bring change in direction of motion, right? Bring change in direction of motion, right? Should I rub this? Yeah, take your time, you write it. Done. Now types of forces, right? In type of forces, we can say that types of forces, right? Types of forces. First is contact force. Sorry, balance force. Okay, if we talk about balance force, balance balanced force, right? It means suppose this is an object, this is a block, right, of wood, right, and forces are applied. There is a force of 4 Newton. There is a force of 4 Newton in upward direction, right? So it is positive, not visible. This is visible, and this is 4 Newton in downward direction. So it is negative, right? And it is towards left. 4 Newton is towards left, so it is negative, and 4 Newton towards right, so positive, right? So as force is a vector unit, so direction is also required, right? It is upwards, it is downwards, it is left, it is right, like this. So what happens in this? Algebraic sum of all forces, algebraic sum of all forces is 0, right? Algebraic sum of all forces is 0, means plus 4 plus minus 4 plus 4 plus minus 4, that is equal to 0. That is balance force, right? And so in this case, on applying, no change in position, no change in position, right? No change in position. Now second we have that we call unbalanced force. Unbalanced force, right? In this, what happens if similarly we take a block, suppose this is a student of your class, right? And and one girl is another student is stretching it towards this direction, say साउथ की तरफ इसको, साउथ इज निगेटिव, सो निगेटिव 4 न्यूटन के डायरेक्शन में मूव करा रहा है, स्ट्रेचिंग, राइट, एंड another student is stretching her towards north with plus 4 Newton, right, plus 4 Newton, and then the next girl is stretching her next student, these all are students, right? Your class. So it is stretching towards west with 4 Newton, with this is minus 4 Newton, but this one is stretching. This girl is student is stretching towards sorry, this is plus 6 Newton, right? So in that case, what happens, right? There are also students, these are also students who are stretching, right? This is also a student who is stretching. So what happens? The overall algebraic sum is not zero, right? Algebraic sum is not zero, right? As towards east, magnitude of force is more, right? Towards east, magnitude of force is more, so object will move towards east, right? Did you understand what I said? So this is unbalanced force, right? This is unbalanced force. Now, what I said here, forces are acting upward, downward, left, right, right? All forces have same magnitude. So when you add these, the sum is zero. है ना? So this is balance condition. Yes. Algebraic sum should be zero. Otherwise, it will not happen. Right? And in this case, you see there are this is the one student, and it is stretched by 4 pupils from towards south, towards north, towards west, towards east. But here towards east, magnitude of force is more, right? So since towards this side magnitude of force is more, so she will be pulled towards east. She will move towards east, right? So that's why it is unbalanced. It causes motion. Due to it, unbalanced force causes motion, causes change in position. Change in position. Is it? Is it visible? So this is we have about balance and unbalanced forces, right? And as per your book, we have, should I rub this? We have so forces type of forces Type of forces based on based on based on position, right? Position among them. Among them, in this we have two types. One is contact force. Contact force, right? Contact force. In contact force, what happens? Hmm? Based on the magnitude, right? And contact force is like this. This is object A, or this is object B, right? So B is putting a force on A, that is called FB. FBA. B is putting force on A, right? And here A is putting force on A is putting force on B. So that is force AB, right? So because of this, so in this contact force, surfaces of two objects in contact of each other, right? They are touching each other, right? Surfaces of two objects in contact of each other. Example is frictional force, frictional force, hmm? Surfaces of two objects in contact of each other. Surfaces of two objects, two, two or more, you can say. Surfaces of two or more objects in contact of each other, like frictional force, right? Muscular force, muscular force, force force applied by stretched stretched spring, right? And forces during daily life, right? In all these forces, objects are in contact of each other, right? There are all the four. Matlab, when two objects are in contact of each other, then it is contact force, right? Now we have non-contact force. Non-contact force. Non-contact force. Non-contact force is like that. There is a magnet, right? It's North Pole and South Pole. It's North Pole, it's South Pole and North Pole. There is another magnet whose huh? This is you are saying, na? Force applied by a stretched spring. Okay, I'll tell you. Just wait. I'll tell you. This is South Pole. Oh my God. Oh man. This is South Pole. This is North Pole. So between opposite poles, between they are not in contact of each other. They are not in contact of each other under the influence of magnetic field, right? Between opposite poles, attraction, right? And between same poles, so there is force of repulsion, right? There is force of repulsion. Same poles, same poles, repulsion, right? Repulsion. This is a kind of non-contact forces between magnets. So this is magnetic force. Magnetic force, right? Magnetic force is a magnetic force, right? Magnetic force. Then we have a charge. We have a charge like this is charge Q, right? This is charge Q plus Q charge, right? 1 coulomb charge it is having, but positive charge, 1 coulomb positive charge, right? And there is another charge of minus Q, that is also 1 coulomb, right? And there is another charge. They are not in contact, they are away to each other, right? Like there A and B were in contact, here they are not in contact, these magnets are not in contact. So this is having plus Q, this is having plus Q, 1 coulomb charge, right? So again the same thing is happening. Opposite charge, opposite charge, opposite charge, attraction, opposite charge, attraction, right? So it it will attract this and this will attract this, right? but between these two there is same charge, right? Same charge. So there is repulsion. Same charge, repulsion, right? It will go this way, it will go this way, right? Same charge, repulsion, opposite charge, attraction. So this is kind of electrostatic force, right? So this is electrostatic force, है ना? This is what we call electrostatic force. Now you have seen Earth, है ना? Earth. So this is Earth. So as Newton told us, there is force of attraction between two charges, right? Hello. There is force of there is force as Newton told us, there is force of attraction between two objects, right, in the universe. So this is and because of that, say we are here, है ना? So its charge is and at the center, so it attracts the person towards it. Earth attracts the person towards it, and so this is attraction force only. And this man is attracted if there is a tree, suppose, on the earth. So there is a tree on the earth. So this tree is also attracting this man, and this tree is attracted by earth also, right? So this is force of attraction only. There is force of attraction only. Force of attraction. Force of attraction only. Attraction. Force of attraction, right? So this is here only force of attraction, and this is gravitational force, right? What we call it, that is gravitational force. Gravitational force, right? Gravitational force. So this is non-contact force or magnetic force, electrostatic force, and gravitational force. But in magnetic and electrostatic force, there are two types of forces, the force of attraction and force of repulsion in both the cases. But in gravitational force, only force of attraction, right? Only force of attraction. So that's why this man is attracting, this tree is attracting, this man is also attracting this man is also attracting earth also, but due to mass, force is negligible. Mass of man is negligible in comparison to mass of earth, right? Mass of earth is around 6.0 into 10 ki power 24 kilogram kg. Did you understand? Mass of earth is 6.0 into 10 ki power 24 kg, right? And what is the, so Earth mass is, Earth mass is 6.0 into 10 raised to the power 24 kg, right? And what is the mass of a man? Maybe man mass is maybe 100 kg maximum. So 100 kg is very negligible in case of Earth. So for that attraction not feels, right? And force of attraction applied by Earth is known as gravitational force. So what is the difference between magnetic and electrostatic force and gravitational force? What is the difference? Huh? You have to tell me. Yeah, yeah. Hmm. Yeah, yeah, because of that, right? Very good. So this is, we have, these are contact and non-contact force, right? Okay, can I rub this? Hmm? Okay. Now you are asking force applied by a stretch spring, right? You are talking, you want to understand that. Okay, very fine, very fine, very fine. I am telling you, you know, force, force applied by a stretched stretched string, right? Okay, you know, this is a fixed surface. Oh my god, this is a fixed surface, right? This is fixed surface. Fixed surface. Okay, we we hang a spring like this, like this, right? Like this. This is a spring. Oh, spring hang with fixed surface, fixed surface, right? Fixed surface. So its length is L, right? What you have done, you put a weight on it. You put a weight on it like this, right? When you do that, then what happens? This spring get stretched, right? This spring get stretched due to the force, due to the force weight, weight of the object W, that is equal to mg, that is a force, right? Due to the weight of this object, this spring gets stretched, right? This is spring get stretched. Spring spring get stretched due to weight hang with it with it, right? So what happens? Weight force is applied in downward direction towards earth, and there is it tries to get its original position, so a force is acting in upward direction also, right? So that we call tension, that we call force of tension, right? Tension force acting on it, that is equal to m into a, right? That is m into a. I hope you understand. So this is what happens when you withdraw this force. Weight, it reaches to maybe its length was initially its length was L, and there is increase in length, that is L dash, right? So the change in length delta L is equal to L dash minus L, right? Due to this weight, there is change in length. You have seen that, you know, spring balance. You have seen spring balance, na? That is something like this, you know, that is having, like a hook here, right? And this is for holding, and there are graduation. There is a spring, spring, and there is attached a pointer, and there is graduations, right? There is graduations. So what happens when you when you hang a weight with it? When you hang a weight with it, what happens? When you hang weight, then what happens? This pointer comes here, suppose comes here, due to the weight. Due to the weight, its position get changed, right? This is the change in position of pointer. This is the change in position of pointer, है ना? Due to the weight there is change in position of pointer due to the weight. This is we have, huh? Change in length, change in position of pointer and this is what this is, and spring balance, है ना? Spring balance. You have read used for measurement of weight, है ना? Spring balance is used for measuring weight, and beam balance or physical balance is used for measuring mass of an object. So spring balance force applied by is stretch spring is like this. Spring gets stretched when a weight is hang on it. What is written in your book? Almost similar, na? Hmm. So this is we have. Yeah. What? Hmm. Yeah. So almost clear. हाँ, जो टेंशन है ना, that is called restoring force. ये जो अच्छा, okay, very fine, very fine, very good. ये जो वेट है, वेट 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 apply deforming force, deforming deforming force, right? So spring get stretched, stretched, right? And this tension force which I am telling, this is a reforming force. It is trying to trying to bring it in a normal position, right? So tension force is a form of reforming force. When you remove this when you remove this weight, then the spring goes to its normal condition, right? So this tension force is a kind of reforming force. There is a reforming force because opposite forces are acting on an object. One is reforming force, which is stretching, spring get stretched, and reforming force. Oh my God! Reforming reforming force, reforming force, reforming force, or reforming force or tension force tries to tries to bring spring in normal position. Did you get me? Normal position, right? Normal position. So reforming force is this tension force, and deforming force is force of weight. Weight and because of this weight, spring get stretched, and this tension force tries to keep it, try to bring it in its normal position, right? So this is deforming force bring change in shape, and reforming force try to regain the original shape. I hope you understand. Okay, so I hope the first section is over now. Okay, so should we continue to second part or you learn this much first? Then we'll come to the next part. I I know that, I know that, I know that. But this much you understand, I hope very well. Now defarming and reforming forces you understand? Defarming and reforming forces you understand very well. Reforming force bring it in normal position. Deforming force brings change in shape or change in length. Right? So okay, this much you learn. Right? Okay then.